In this video, we're going to go over section 3.2 class notes problems. So first, we want to write negations of universal statements. And for that, we just got to remember a couple rules. So the first rule is that when we're negating a statement of the form for all x, p of x, then we're going to get an assist x so that we have negation of p of x. And that we're negating an existential, then we do the opposite. The existential becomes a for all, and we negate p of x. Okay, so with that logic, when we write the negation of each of these statements, we're going to get the following. For the first, we have all the dogs are mammals. So we're going to get like some dogs are not mammals. An equivalent way will be saying there exists a dog that is not a mammal as well. Here we're saying every integer is positive or negative or zero. Notice that we're negating a statement with various ors. So positive is P, negative is Q, and zero, I'm going to call it S. So I'm writing pretty much something that is from the form it says X so that P of X or Q of X or S of X. This is the type of a statement that we're negating right now. So we're going to negate now. We're going to get a for all negation of all this, and this is going to flip the or for an n. So we're going to get for all x negation of p and negation of q and negation of x. So we'll say all integers are not positive and negative and zero, which kind of makes sense that they're not all those things at the same time. Okay. Now, here we have a symbolic negation, so it's going to be a little bit more easier. The negation of the for all is in assist, so assist x so that assist x that belongs to R, so that x squared is less than 0. The negation of x squared bigger than 0 will be x squared less than 0. Now for D, we have for all n that belongs to the integers, n plus 1 is bigger than n. So if we want to negate that, we'll say it says n that belongs to the integers so that n plus 1 is less or equal than n. Now that statement is true or not, that's an entirely different story, but at least that's the negation. Now let's same thing, but with some other examples. We have some cats are black. We can say all cats are not black. So we flip the quantifier and then we negate the predicate. There's a student who has seen the movie. Okay, so this is negation of an existential. So all students has not seen the movie. Probably there's a better way to write this out. You can kind of say no student has seen the movie, which will make much more sense in English. Okay. Now in C, for all x that belongs to R, and then we negate the predicate, x squared is different from 2. If we negate this one, we'll have for all n that belongs to C, n squared is bigger or equal than n. All right. So once again, we're always flipping the quantifier and negating the predicate. Now, question number 3, write the negation of each of the statement in symbolic form. So now we just got to be careful with the symbolic form because you want to make sure that you're negating correctly the property. So here for all, then it becomes an assist. It says x that belongs to R, so that x plus 5 is less or equal than x. The negation here is by flipping the sign. Negation of an assist for all n that belongs to C. We have that 2n plus 1 is going to be different from 2n. The negation of the equal is that the fact that they're not equal. For all the student S owns a calculator. So you can say assist a student S with no calculator, or that doesn't own a calculator. D, negation of assist prime P such that P is even. You can say for all prime P, P is odd. In this case, odd will be the negation of even. Now, question number 4. We're going to negate each of these statements, and we're actually going to say here if this is true or false for the original. All squares are rectangles. This is true, by the way. And the negation of this will be assist a square that is not a rectangle. Of course, because the original is true, then this is going to be false, since the negation has to be false. Some prime numbers are even. This is true. In particular, n equals 2 is prime and is even. The negation of this will be all primes are odd, which then is going to be false. Most primes are false. All of them except 2 are odd. Okay. Remember, this sum is an assist, so the negation of sum is all. Now, question number 5, write the negation of each universal conditional statement. So all these are universals, and we're going to negate this with existential. So negation of for all, x that belongs to R, is x that belongs to R. And then we have an implication. So remember that the negation of the implication is that we have P, but we don't have Q. So if x is bigger than 5, then x is bigger than 0. So the negation will be here, x is bigger than 5, and x is less or equal than 0, which is the negation of this. Now, another implication, it says n that belongs to C, and we have the implication if n is even, then n squared is even. So now we're going to have, well, n is even, and n squared is odd, which will be the negation of the conclusion of Q. Now for C, for all x that belongs to R, if x squared is equals 4, then x is equals 2. The negation of this will be assist x that belongs to R, so that x squared is equals 4, and x is different from 2. Remember, negation of P implies Q is always P and not Q. That's what we're using here. All right, question number 6. We have write a negation for all integers n. If n is divisible by 4, then n is even. Okay, so let's write the negation in symbolic form. So this is first and then this is for all n that belongs to C. N is divisible by 4 can be written as 4 divisible by n, and then n is equals to k. Will be symbolic of this. The negation of this in symbolic form is that it says n that belongs to C, so that 4 is divisible by n, and n is not even. So odd can be written as 2k plus 1. And this is, of course, is for certain k that belongs to the integers. Now the negation in English will be is assist an integer n divisible by 4, but odd. This but function is the in, and odd is the negation here. Is the original statement true or false? Well, the original statement is going to be true. Notice that if 4 is divisible by n, that implies that n is 4k. And it's 4k, then is twice by 2k. So it's twice by s. So that implies is even. So this is original statement is true. Is the negation true or false? Well, because the original is true, then the negation is going to be false. Okay? So let's continue with more examples in part 2 of the class node examples.